one, here we have our second derivative is equal to a times the square root of 1 plus the first derivative squared. And I'm checking this y is equal to e to the ax plus e to the negative ax over 2a. So when I substitute in, I'm going to substitute in for the first derivative and for the second derivative. And so let me start by finding our first derivative. In this case, y is a derivative of x, so that 2a is considered a constant. You could just pull that out, 1 over 2a. And we're really just taking the derivative of this numerator. And because these are exponential functions, taking the derivative, you're going to just pull down that coefficient of x. We're going to get a e to the ax. And for the second term, the derivative of e to the negative ax, you're going to bring down that negative a. So you get minus a e to the ax. And now here, because I have an a in the denominator and I have these two a's in the numerator, all these a's will cancel out. It gives me 1/2 e to the ax minus e to the ax. And then for my second derivative, again, this 1/2 is a constant that just carries. And we're just doing this derivative of e to the ax minus e to the, actually this should have been a negative ax. That should be a negative there, and this should be a negative there. And so that 1/2 is just going to carry in front. 1/2. The derivative of e to the ax is a e to the ax. And the derivative of e to the negative ax is going to bring down a negative a. So I'm going to have the opposite of a negative a, which gives me plus a. And then my exponential comes back, e to the negative ax. And from here, if you want, you could factor out the a. I think I'll leave it like this for now. And now let's substitute in. Because I have derivatives on both sides, I'll have to substitute in both sides and then show that both sides are equal to each other. So let me show the left side. Our second derivative we know is equal to 1/2 times a e to the ax plus a e to the negative ax. That's what we have over here. And on the right side, I have a square root of 1 plus derivative of y squared gives me a square root 1 plus the derivative of y is this 1/2 e to the ax minus e to the negative ax. That's going to go here. 1/2 e to the ax minus e to the negative ax. And that's another parenthesis squared. Excuse me. Okay, I'm sorry about that. I had a phone call. But here we want to show that the right side of the equation is equal to the left side. And the left side is just our second derivative. So we want to simplify the right side. And here I want to start by squaring everything inside this larger set of parentheses. And so my my a is still here. And I've got 1 plus, here I want to square my 1/2. That'll give me 1/4. And then squaring e to the ax minus e to the negative ax, we're going to get e to the ax squared. That's going to actually give you e to the 2ax minus 2 times the product of these two. I'm going to write that down. Minus 2 times ax, e to the ax, times e to the negative ax, and then plus this second term squared. E to the negative ax squared is going to give you e to the negative 2ax. That square root goes over everything. Here when I squared these, e to the ax minus e to the negative ax, I use the formula for square of a binomial. If you have x plus y squared that gives you x squared plus 2xy plus y squared. It's a formula for squaring two terms. Okay, so let me come back here. Okay, so simplifying underneath this square root, I'm going to start by writing 1 as 4/4 because I see this 1/4 so that I have common denominators. And e to the 2ax, I'll copy that, minus 2e to the ax times e to the negative ax. When you multiply this e to the ax and e to the negative ax, you're adding the exponents. It's actually a formula. A to the n times a to the m gives you a to the n plus m. Come on. M power. If you're multiplying and you have the same base, you add the exponents. So here I have the same base, e, in both cases. I want to add the exponents. When you add the exponents, it gives you a 0 exponent. It'll give you e to the 0 power, and anything to the 0 power is 1. So this second term becomes negative 2 times 1, or just negative 2. And then I have plus e to the negative 2ax Now, because you have a common denominator here, you could place everything over 4. Whoops. I have a hard time drawing straight lines. Everything over 4. And then you're going to have 4 plus 1 times all of this, which gives you e to the 2ax. When you add 4 to negative 2, that's going to give you a plus 2 plus e to the negative 2ax equals okay, and I still have the a outside. Now notice that I've got the square root of 4 on the bottom. I can bring out that square root of 4 and that'll give me a 2 down here. And underneath my square root I've got, let's see what we have. We have e to the 2ax plus 2 plus e to the negative 2ax. Notice that that's very similar to what I had up here. E to the 2ax minus 2, because this canceled, plus e to the negative 2ax. The only difference is that instead of a minus, I now have a plus in front of that 2. this e to the 2ax plus 2 plus e to the negative 2ax is a perfect square, and it factors into e to the ax plus e to the negative ax squared. And now this square root and that square are inverses of each other. They cancel each other out to give you a over 2 times e to the ax plus e to the negative ax. And notice that this is our second derivative. That is the second derivative. If you take out the a, you've got a over 2 e to the ax plus e to the negative ax.